Good morning, everyone. So today we are going to go through 5.6. So technically word problems isn't its own thing. So 5.4 and 5.5 we actually skip over in this chapter. We're going to do 5.6 today, which is just graphing a linear inequality, which is just like graphing a linear equation, but there's a couple extra steps. And then tomorrow, or I guess Wednesday, later in this week, we're going to go over how to graph a system of linear inequalities. So just like a system of equations is two equations, a system of inequalities is two or more inequalities that we're going to graph all at once. And with equations, we had all sorts of methods of solving. We could use substitution or elimination or graphing. The nice thing about inequalities is really the only way to solve them, or the only way that we're going to deal with, is graphing. Okay, so we really only have to learn one method, and that's pretty much it for chapter 5. I know there's some other stuff in this packet, but we're going to skip all that linear programming stuff. So we have to learn how to graph one linear inequality. So we're going to do that today. So let's go through some definitions here. Okay, a linear inequality in two variables. Here's this kind of long explanation. It's an inequality that can be written in this method. So basically in standard form, either less than C, greater than C, less than or equal to C, greater than or equal to C, and A, B, and C are all real numbers. So really think of it just like a regular linear equation, okay, like a y, or here, let's use the numbers they're using. Okay, so ax plus by, okay, normally with an equation we'd be equal to c, but now we can be greater than or equal to, less than, okay, any combination right there. All right, so a solution of one of these linear equalities, well, that's just an ordered pair that makes the inequality true. Okay, so a solution of an equation is basically any point that falls along that line, but an inequality is going to have way more solutions because it's not just everything that falls on the line, it's everything that falls on like that half of your coordinate plane. All right, so the graph, kind of like I was just saying, the graph of this is the graph of all of the solutions to that inequality. Okay, and then half planes. I don't end up saying the word half planes too much, but it's nice to see it. Okay, so basically you have a coordinate plane, right? You've got your y-axis. This is pretty messy. You've got your x-axis. You're going to have a line for your inequality. And then you're going to say, okay, well, this half of my line is all true. On that side of my line, everything is true. So you divided it into two half planes. Okay? We could call it like side 1 where it's not true and side 2 where everything is true. And I'll get into more how we decide what side to shade and everything like that. But the side that you shade is all the solutions, okay? Remember, because it's not just the line, it's everything to one side of the line are going to be solutions to this inequality, okay? So there's two things that we have to add on, other than just, graphing the line, which is what we've done in the past. Now we have to think about, is it going to be a solid line or a dashed line? Okay, so a solid line would mean that the symbol is greater than or equal to, or less than or equal to. Okay, kind of like the closed circle and open circle. This is like a closed circle. It's a straight solid line. Okay, so a solid line, just like a normal line that you would draw. Okay, a dashed line would mean that you have just greater than or just less than. Okay, so a dashed line looks like that, like a dashed line. Okay, so that's the first thing we have to decide. Okay, so you really don't want to do this stuff with pens. You really want to use pencils because that's the worst thing ever. When you draw the solid line, you realize, oops, that was supposed to be dashed. You want to just be able to erase it into the dashed line. Okay, it's really annoying if you're using pens. All right, and then which side to shade? Okay, like we said, with all these inequalities, we're basically going to color in one side. Okay, so if you have like colored pencils or a highlighter or whatever, something like that, that's what we can use to color in one side. You can use your pencil too, of course. Okay, so let's go into, first off, let's go into checking solutions, because that's going to be a step we have to do in these different inequalities. Okay, so check whether the ordered pair is a solution of this inequality. So we have this inequality here, this 2x plus y, and then we have this solution, that 1, -9. So it's telling us to go in and check whether this solution is true or not, whether this is actually a solution. Okay, well, it's giving us an ordered pair, so I know that's x. I know that's x and y. So I'm going to plug these numbers in, okay? 2 times 1 plus y, so plus -9, is less than -3. Okay, so 2 minus 9. I skipped a step in my head there, huh? 2 minus 9 less than -3. Okay, 2 minus 9 is -7. Is that less than -3? It is. So yes, it is a solution. Okay, see how that works? If you plug in the values and the inequality is true, it is a solution. So let's see if this one is true. If it's not true, then it's not going to be a solution. Okay. If you get the x and y on these points mixed up, you can always just write x and y, kind of help you remember. I remember I always used to get that mixed up, and it would make me so frustrated. Okay, so x is 2 minus 3 times y, so -2 greater than or equal to 8. Okay, so 2, okay, -3 times -2 plus 6 greater than or equal to 8. Okay, so is 8 greater than or equal to 8? It's not greater than, but it is equal to, so that works. Yes, this one is a solution. Okay, if it had just been greater than, it would have ended up being not a solution. Okay, but both of these ended up being solutions. All right, looking through, making sure I didn't do bad math on any of these. Okay, so let's move on. Let's go ahead and actually graph one of these linear inequalities. Okay, so it says to graph y is less than or equal to 2 in a coordinate plane. Okay, so it says since it is less than or equal to, we will use what type of line? Okay, remember, when it's or equal to, that means you're including everything on the line. So we're going to use a solid line. Okay, the line is, think of it like this. When the line is included, okay, we're using solid because that's telling us the line is part of it. If the line is not included, we use a dashed, and that's kind of our signal. Okay, everything but this line, we're not counting the line, is part of the solution. Okay, so that's kind of how you can remember. Okay, and to decide which side of the line to shade, we're going to test the point 0, 0. But before I do my test point, I like to actually go through and draw my line. Okay, so when you draw the line, it's just like a normal equation. So I could think of it like y equals 2, if that helps me, if that sign is messing me up. I'm not going to leave that up because I don't want to confuse you and think that we're graphing the equation. Okay, but it's just the same as y equals 2 when we're just graphing the line. Okay, so I know that y equal to a number is just a horizontal line at that number. I'm going to see, do I have a line? Yes. I don't think that'll work for my dash lines, but I can at least do that for my solid lines. Okay, so I have my line at y is equal to 2. So then I also have to decide one of the sides of my line is going to get shaded in. So I have to decide which side that is. Okay, so we're going to test the point 0, 0. Okay, so I'm going to plug that in. So y is less than or equal to 2. I'm going to plug in 0 for y. Is 0 less than or equal to 2? Yes. So that means I'm going to shade in the side of my line that includes 0, 0. Do we see how this works? Okay, We're always going to test 0, 0, unless the line goes through 0, 0. Then we're going to say, okay, whatever side of the line has 0, 0 is either going to be true or false. So since this one is true, we're going to shade in this part of my line, okay, that includes 0, 0. If it had been false, I would have shaded this side of my line, but it was true. Okay, so you're thinking, what side of my line includes that 0, 0 point? And obviously I didn't mean to go over the line on that one little bit, but I can't really erase it. All right, so again, because 0, 0 made our inequality true, we're shading the half planes of the side of our line that contains 0, 0. Okay, if it makes it true, then shade the side of the line that has the test point. If it was false, we would shade the side of the line that does not have that test point. Okay, so let's do here. Why don't we do something with x is greater than 3? See if you can sketch this one out or have an idea what it would look like. I'm going to, if you want to pause the video quick, and then I'll just do that on my own, and you can see if ours matches up, rather than me explaining through the whole process. Alrighty, so hopefully we ended up with something that looks like what I have right here. Okay, we have that vertical line there at 3. We know that it should be a dashed line because it is just greater than, it doesn't have an equal. And that point 0, 0 was false, so I didn't shade the side that included 0, 0. Okay, it was false, so I shaded the side that didn't include 0, 0. Okay, and that's the thing sometimes people don't get. The 0, 0 thing, we could really use any point that we wanted to, but the math usually ends up working out pretty easily with a 0, 0. So you could guess 8, -8 if you wanted to, but that point just isn't as easy to find on your graph or to plug in as 0, 0 is. Okay, let's look at some more examples. This video might be kind of long, but that's okay. All right, so we are graphing another linear inequality. So we have negative x plus 2y is greater than 2. So first off, decide if it's solid or dashed. We can see that this one is going to be a dashed line because it's just greater than. Okay, I don't really like graphing in standard form, so I'm going to convert this line to slope-intercept form because I think that's the easiest way to graph. So negative x plus 2y greater than 2. So we dealt with inequalities before. I just want to move this around so it's in that y, it's not really equals mx plus b. Okay, it'll be like y is greater than or y is less than or something similar to that, to mx plus b. Okay, but still the same concept. Okay, so I'm going to add x to both sides. Okay, so I get 2y is greater than x plus 2. Okay, I'm going to divide both sides here by 2. So I'll get y is greater than, okay, x divided by 2, that's like 1/2 x. And 2 divided by 2 is 1. Okay, so y is greater than 1/2 x plus 1. Awesome. I know this is a dashed line. I know my y-intercept is 1, and my slope is 1/2. So that's going to be up 1 over 2. So I'm going to draw a couple points here. It may not be the most exact line, and this is kind of hard on the computer screen. And then I'm going to make this into a dashed line. And again, I'm working on my computer screen, so it may not be perfect, but I'm going to do my best here. All right. So pretty clearly a dashed line. Again, if you accidentally make it a solid line because that's what you're used to, just erase the little spaces and make it a dashed line. Okay, now I want to test my point 0, 0. I could test it in my original equation. I could test it in my slope-intercept. I keep saying equation, I mean inequality. It doesn't really matter. I'm going to do the original equation. Okay, so I'm testing that 0, 0 point, so I'm plugging in 0 for x and 0 for y. Okay, this is why we use 0, because it's pretty easy. Okay, 0 greater than 2, that is false. So I'm not, okay, I can see where 0, 0 is. I'm not shading that side. I'm shading the side that does not include 0, 0. Okay, pretty much the same process for all of these. All right. Real quick, this one's already in slope-intercept form. I just want to do one more, just so we can really understand this whole process. Okay, first off, I want to think solid line or dashed line. It's or equal to, so I know that's a solid line. It's already in slope-intercept form. Awesome. So I have a y-intercept of -1. Slope is -3, so -3 over 1, so down 3 and over 1. Okay, down 1, 2, 3 over 1. All right, I'm going to draw my line. Okay, luckily this is a solid one, so I can use my little shape tool. Okay, so then I'm not quite done. If it just looks like a line, you know you're not done. You know that each of these should have one of the halves of this graph shaded. Okay, I'm going to check this point here at 0, 0. See if that's the side I should shade or the other side. Okay, so I'm going to just plug in 0, 0. Okay, 0 for y, 0 for x. Okay, so I'm going to see, is 0 greater than or equal to -3 times 0 minus 1? Again, this is why we use 0. So is 0 greater than or equal to -1? 0 is greater than a negative number, so yes, it's true. And so I'm going to shade the part that includes 0, 0. Okay, I know I went over my line. Try not to, but it's not a big deal. Okay, as long as I can obviously see which half of the graph you're shading. Don't shade the whole thing and hope that I'll give you the point. Okay, so hopefully this makes sense. If not, I will explain all this in class. I know this is a lot of new information. I'm not going to expect you to get every little bit of it from a video, but I just wanted to make sure this was out just so you could get kind of all the information in advance. And then we will do this on Monday and Tuesday in class, and we will do systems, which is when we graph two of these together. We'll do that on Wednesday and Thursday, and then we will test that next Monday, February 8th. So just make sure you're ready for that, and I'll see you guys soon.